calculus integration. So, as per the terminology is integration means addition. Okay. Then why there is a term called calculus? It is very similar to we have calculator and we have computer. So that also compute and this also compute. If I take only the ALU, then both are same. Okay, so now calculus integration. How we do the integration and how we do the addition and how it is different from actual addition. So, what is addition and what is its different way to calculate the addition? Like, if I start with the collection. So, if I collect 5 balls in 1 hour, so now I don't have any ball in my hand. And after 1 hour, if I see, then I have 5 balls in my hand. So 2 hours, 3 hours, end of every hour, 5 balls gets added. What about at the end of 12 hours? Okay, so 5 plus 5 plus 5, 12 times. Okay, that would come to around 60. So addition is collection. Every time duration we collect something, and at the end of some particular duration we see how much we have collected. Now this is one way to add 5 plus 5 plus 5 plus 5. There are many ways to add. Another way to add is 5 into 12. Okay, so we call it multiplication. First is addition. Another way to add is multiplication. So multiplication is addition only when it is uniform. There can be another way of addition. First our collection is 5. Next our collection is 10. Third our collection is 2. How much collect? 5 plus 10 plus 2. That is 30. Now I cannot do a multiplication. 5 into 3 or, okay, so 5 plus 10 plus 2. So that is 17. Okay, so I cannot go for multiplication because it is not constant. So if addition is constant over a period of time, then I can go for multiplication. Otherwise, I have to keep adding one by one, the way we added like a histogram kind of fashion. What about 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 up to 100? Okay, I think it is very big. 1 plus 2 plus 3 plus 4 plus 5 up to 10. Okay, so 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10, like that up to 10. Only 10. Okay, I believe no one would dare to do that. It is that difficult. So, this is another way of one addition we saw that we can add. If it is constant, then we can multiply. If it is like this, 1 plus 2, so it is growing. So, first our collection is 1, second our collection is 2, third our collection is 3, fourth our collection is 4. What is after end of 10? So there is a funny way to do that, like 1 plus 2 plus 3 up to 10. If I write, this is one line. In next line I can write 10 plus 9 plus 8 plus up to 1. And then I can add it. So it will become 11 10 times. So 11 into 10 by 2. Okay. So that is 11 into 5. What is 11? What is 10? And what is divided by 2? What is multiplication? What is if I keep on adding? Okay, what are those? Is there any similarity among those? We go for permutation, we go for combination, we go for many Fibonacci series and so many. What is common among all this? Okay, so that I can say now I can do all the form of addition, multiplication, addition, and now we describe the series 1 to 10, and we reverse 10 to 1, we added, and then 11 into 10 by 2. Can we draw a graph? Okay, so like in 1 hour, I collect 5, next hour 10, then next hour 2, then 5, 10 and 2. So in 3 hours, this is the graph. So 3, I would say 3 rectangles are coming into the graph connected. If I get the area of this rectangle, then I am done. 5 balls per hour after 12 hours, 5 balls up to 12 hours, 5 into 12, that is also an area. 1 to 10, so it is growing like this. Okay, it is a triangle. If it is a triangle, then if this is a triangle, then if I copy paste the triangle again in reverse fashion, it becomes a rectangle. And if it becomes a rectangle, its area is width by height. That is 11 into 10. So first is triangle 1 into 1 plus 2 plus 3 up to 10, because it is increasing, so it forms a triangle. If I copy paste, if I multiply it by 2, in next row I place 10 into 9 into 8, then it is 2 triangles opposite to each other. And it becomes a rectangle, and which has one side is 11 and other side is 10. So if I know the area of a rectangle, then if I divide it by 2, then I get the area of the triangle. Okay, so what is common among everything? Means all forms of addition. Area. If I calculate the area of whatever addition, we draw the map of addition where it would vary the kind of the independent variable is like time, the way we talked, and dependent is its values. And if I draw an area, and if I draw a curve, and if I get the area, I get the addition. One form is multiplication, I am sorry. That is integration. We are talking about calculus integration. Calculus integration is nothing but a form of addition, where addition is calculated through area of the graph. So whatever we want to add, we draw. So one axis, x-axis, we take as independent variable like per hour collection, per day collection, per second collection, and then its values we draw. Sometimes we call it speed also. Like a man is walking, he is collecting 5 kilometers every year. A man starts, and at the end of 1 hour, I see he has collected 5 kilometers. At the end of another hour, he has collected 5 kilometers. At the end of 6 hours, how much he has collected? So, x-axis up to 6 and y-axis 5, 5, 5, 5. So, it becomes a rectangle. 5 into 6. So, 30 kilometers he has collected. 5, we call it speed also, rate also. 5 kilometers per hour. 5 kilometers per hour means every hour he is collecting 5 kilometers. Okay. 1 hour, 2 hours, 3 hours. At the end of every hour, okay, so collection grows, net collection grows. How much is the net collection at the end of 6 hours? So, or he collects 1 kilometer at the end of 1 hour, 2 kilometers at the end of 2 hours, and 3 kilometers at the end of 3 hours. means at the end of 3 hours, total collection is 6 kilometers. If that is the way, at the end of 10 hours, how much he has collected? It is equal to what we talked, 1 plus 2 plus 3 plus 4. So, it becomes the area of the triangle. Okay, so now if we know that everything, every path, every route in addition, they meet in area of the shape, then can we go for more analysis? Means when I know that every river meet at this point only, then I can do research on that water rather than collecting from everywhere. Okay, so what progress we can make? How it can help us just getting the area of something. So for a person, like we talk 1, 2, 3, 4, a person is walking or collecting distance and it is not smooth. It is not constant, like 5 km per hour. Okay? It is very intricate, means he is changing. Like we talk 1 plus 2 plus 3. So we call it x. If horizontal axis is or t, time while we are collecting, then independent variable is t, then dependent variable, how much kilometer per hour he is collecting, that is also t. So at the end of 1 hour, he is collecting 1 kilometer. At the end of 2 hours, extra 2 kilometers he is collecting. So it becomes like you can say ramp. Okay. So in that case, now what would be how much he has collected? So I would say if it is x, then it is a triangle, or it is t, then it is a triangle. At the end of t hours, if I make it a rectangle, then it is t square, half t square by 2. So I can say, if I integrate t, equation of t, at the end of t hours, it is t square by 2. If it is constant, like 5 km per hour, so 5 is constant. At the end of t, it is 5t. Someone says that you just did the multiplication. So, if it is a constant, then just we put t. If it is not constant, if it is a t, then t square by 2. Like that, we do calculation of some few basic things. Because bigger thing, they sit on collection of basic things. Okay, there is nothing new. Like addition, multiplication, then we'll go for exponential, logarithmic, sine, cos, tan. Everything would sit upon the simple things. So if I know this way, if I calculate a few basic things of the integration, then bigger things we can get. What about someone is working in a sine wave? He started from the 0 and then his collection grows, and at end of pi by 2, at that moment pi by 2, total collection is 1, or I can say at that moment, at the pi by 2, he was collecting 1 km per hour at that moment. Okay, since it is smooth, okay, line is highly intricate, means any moment it would change. We were talking about every hour it is changing. Here, every moment it is a smooth curve. And after pi by 2, his collection per hour, means whatever you say, per moment is decreasing. And at pi, his speed is 0. So how much he has collected? Then after pi, since it is a sine wave, it is negative. Negative means he is coming back. And at 3 pi by 2, okay, his speed is -1. Means again he is at peak of his speed. And okay, how much net he has collected up to 3 pi by 2. And at pi, he came back. So total collection is 0. Because area is 0. Plus half minus half. So now if we learn calculating the area from basic to complex, so now if I take the sine x equation, it would be variation in x only, or sine t variation, it would be variations of some t plus 1 by t and t 1 by t square whatsoever. So if I know basic, then the integration of sine comes as cos t. Okay. So if I collect, I think I am right. So integration of sine t is cos t. So cos 0 is 1 and cos, I believe it is minus cos t. Okay. So it is one of them, cos t or minus cos t. So if I want to calculate how much he has traveled up to pi by 2 and it is sine t. So at the pi by 2, okay, now area I have to collect. So at the time of 0, it is anyway 0. And so if I say the integration of sine t is cos t, okay, then area between 2 is like any two slices is beginning area and another area and difference. Means I think we will show in the slides. Then the bigger area, that is cos 90. So cos 90 is 0 and cos 0 is minus, cos 0 is 1. So integration of sine t is minus cos. Now it's clear. So 0 minus 1, so 1. So if person walks in a sine wave and up to pi by 2, total distance he is covered is 1. Next pi by 2 he covers 1, so 2 he has covered, and then minus 2. So integration comes into the picture when we add things that is continuously varying and it is managed by some kind of equation. Okay. So anyway, whatever we are doing, all are through equation only. If I say 1 plus 2 plus 3, it is x. Okay, it is a kind of a ramp. Or if he collects 5 km per hour, then it is a flat. But it cannot be smooth ramp. It can be sinusoidal, it can be cos, it can be tan, it can be log, it can be exponential. So if I want to calculate the total addition, then we go with another terminology called integration, and that is nothing but calculating the area of, if I draw the graph or curve of the addition, then during that duration, how much is the area, that is the total correction. Okay, so we will proceed on that and we will see kind of really interesting and funny things that we believe that it is difficult if we do go for a multiplication or simple addition. That will see.